having uh, built a power circuit, a series circuit, we are going to put the two of them together and we build a series parallel circuit. So I'll employ some two resistors first to build a parallel circuit. So by connection, these two resistors are in parallel. They are connected in parallel. Okay. The third resistor will be in series to the two resistors. So I'm connecting only one terminal of the third resistor to the two resistors. Okay, so these two resistors are in parallel and they are in series with this resistor. What I'll do is that I'll connect dampers to them. Okay, so I've gotten a series parallel arrangement of three resistors. All right, I want to make a meaningful circuit now. So what I'll do is that I'll connect the the three resistors, then I'll connect them to this LED. Okay, and then I'll put it here for power, and then here for neutral. By connecting the battery terminal, so what is happening here right now is that current flow through this wire to the LED and through to this. The purpose of the resistors in here is to limit the current that goes through the circuit. So it's limiting the current that goes through the circuit. Alright, so the two resistors in parallel has reduced the resistance to a certain limit. Okay, so let's see the effect of that. By taking away the resistor which is 10k, then we replace it by a short from the resistors that are in parallel to the LED. You see the effect it will have. See the effect it will have. See, you have to be careful as to where to slot the connection. If you miss the slot, everything goes off. In the initial stage, I missed the point. Now, if I fix at the right point, I'll get it done correctly. That is it. So, you see the resistor in series has increased the resistance in the of the circuit. But when resistors are connected in parallel, they reduce the resistance of the circuit. Initially, the light was glowing dim, or the LED was glowing dim, but when I took off the resistor that is connected in series, the resistance reduced, hence the current increased. I can still prove that by taking one of the resistor out. See, this resistor has begun heating. Yes, because it's struggling to supply the current. So I have to connect the second resistor to permit more current to flow in the circuit. Okay, I would like to introduce the variable resistor to the circuit. By introducing the variable resistor, we can regulate the luminous intensity of the LED. If I want to do that, I have to connect the middle terminal, which is the variable section, to the one extreme terminal. So from here to here, that's from the middle terminal of the variable resistor to the last terminal of the variable resistor. Then I will connect it to the positive side of the LED. So it is connected like that. So the variable resistor is connected to the LED. Now what do? I will now connect from the battery lead remember, all these are connected horizontally to this section. So I cannot take it from here to the first terminal of the variable resistor. Okay, now I can take from the negative lead to the resistors in parallel. Alright, let me regulate it. See that. See. So by using the breadboard, I can do a lot of measurements. I can take off this resistor and conduct measurements or test the current that is flowing or the voltage that is passing through this resistor. I can check the voltage that reaches the LED. I mean, I can do a lot of things by testing and experimenting. I can change a lot of things and do that. So the breadboard is really for experiment, okay, or to practice. When one is uh, well when one is well abreast with the LED, so when one is well abreast with the use of the breadboard, the person can now progress to solder on a matrix board. Thank you for watching.